from Space Launch Complex 41 at Cape Canaveral Air Force Station, Florida, Lockheed Martin Commercial Launch Services and United Launch Alliance present live coverage of the launch of Atlas V AV-014 on board the ICO Global Communications G1 satellite. This is Atlas Mission Control, a T-minus 10 minutes and counting. A few minutes from now, an Atlas V launch vehicle is scheduled to lift off with an ICO G1 satellite for ICO Global and Lockheed Martin Commercial Launch Services. Launch countdown operations are continuing, and the launch vehicle and spacecraft teams are conducting the final pre-flight checks. The team is not working any issues at this time, and the launch window opens at 4:12 p.m. Eastern Daylight Time and remains open for 60 minutes, closing at 5:12 p.m. Eastern. Good afternoon and welcome to Cape Canaveral Air Force Station. I'm Don Spencer. We're very pleased to have you with us live from Mission Control here at the Atlas Spaceflight Operations Center at Cape Canaveral. Later in the afternoon's broadcast, you'll hear the voice of Rob Gannon as he provides the launch vehicle ascent data from the telemetry lab. Today's Atlas V launch vehicle is carrying the ICO G1 satellite for Reston, Virginia-based ICO Global Communications. The ICO G1 next-generation satellite will deliver advanced video and interactive services to mobile consumer devices. With this launch, ICO will become America's first now. The satellite has a 12-meter unfurlable mesh reflector and weighs in at approximately 6,634 kilograms, fully fueled, which is approximately just under 14,600 pounds, making it the heaviest satellite ever launched on an Atlas launch vehicle. The satellite will be located at 92.85 degrees west, providing ubiquitous coverage over the United States. And there is a weather briefing occurring as we speak. Right at this moment, they're closing the weather briefing. We had an earlier weather briefing. This briefing is expected to be consistent with the earlier briefing. The outcome of that weather briefing indicates we have a probability of violating weather constraints during the launch window this afternoon of 30%. The paint or the thickness of the cloud decks in the area as the front passed through. Starting yesterday, however, look out the window here just a short while ago. We don't have major concerns at the moment. We have some scattered clouds that are not forming into solid cloud decks. So we're looking pretty good. Ground winds are well within the constraint in the 10 to 18 knot range, and our upper level winds are also within constraint. Temperature is about 70 degrees Fahrenheit here at Cape Canaveral, so an excellent day for a launch with blue skies and very light clouds in the area. So the team is at this time not working any issues, and we'll go for liftoff. Again, T0 planned for 4:12 p.m. Eastern Daylight Time, 2012 Greenwich Mean Time. We have a 60-minute launch window available. Again, it closes at 5:12 p.m. Eastern, 21:12 Greenwich Mean Time. This afternoon's Atlas V vehicle is flying in the 421 configuration. It's powered by the RD-180 main engine, a single-engine Centaur upper stage, and two strap-on solid rocket boosters, or SRBs. As we approach readiness polling, which will occur at T-minus 7 minutes, or L-minus 7 minutes, we'll continue to provide you updates as we progress through the countdown. Again, not working any issues at this time. The launch vehicle, ground systems, the weather, eastern range are all in a go status. So let's take a look at the journey the spacecraft and launch vehicle have taken up to this point. The Atlas V booster and Centaur upper stage arrived at Cape Canaveral on November 5th and November 6th, respectively. The Atlas booster and Centaur were erected on January 18th and January 28th, respectively. The ICO G1 satellite was delivered to Cape Canaveral on February 28th. And on March 28th, the ICO G1 spacecraft was encapsulated within the 4-meter diameter payload fairing, which you're seeing watching the taped broadcast video here. The payload fairing was mated to the Atlas V booster on April 2nd at Complex 41. And finally, the fully integrated Atlas V was rolled out to the pad at Complex 41 yesterday morning at 10 a.m. Eastern. And you can see the tape of the rollout here as the Atlas vehicles rolled out on its mobile launch platform. The 1.4 million pound platform is used to erect the vehicle in the vertical integration facility. Spacecraft is then mated to the launch vehicle, and the full stack is rolled out to the pad. In a typical launch scenario, we are rolling the vehicle to the pad the day prior to launch. However, we can roll the vehicle out as short as 8 hours prior to liftoff out to the pad at Complex 41. And this again is a tape from yesterday's rollout. This is Atlas Mission Control, T-minus 14 minutes, 6 seconds, and counting. And preparations are continuing for the launch today. Now, we're now going into the planned 10-minute built-in hold. And just a moment ago, we entered the planned 10-minute hold, which is T-minus 4 minutes. We were seeing the L count, or at 13 minutes, 45 seconds, and counting away from launch. Coming up in the next few minutes, we'll have at L-7, we'll have our final readiness briefing. The team will be told one last time for the pickup of the countdown.
This hold is designed to allow launch conductor Ed Christensen and the launch team some time to address any tasks that may have fallen behind on. However, right now we're not working any issues, so no issues to work during this hold. So again, liftoff is scheduled for 4:12 p.m. Eastern. And now that we're just entered this built-in hold, we do have, we'll take a closer look at the ICO mission here with a short mission profile video while we have a few moments. This is Atlas Mission Control at T-minus 4 minutes and holding.
The following profile details the important events of this mission using approximate times. The Atlas V AV-014 rocket will launch and deploy the ICO G1 satellite for ICO Global Communications and Lockheed Martin Commercial Launch Services.
This is Atlas Mission Control at T-minus 5, 4, 3, 2, 1. And the RD-180 engine roars to life and liftoff.
The Atlas RD-180 main engine and strap-on solid rocket boosters ignite to lift the vehicle away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile. This will minimize aerodynamic loads. During the first 33 seconds of flight, the RD-180 engine will operate at 100% throttle. At 25 seconds into flight, the vehicle will begin a zero angle of attack flight through maximum dynamic pressure. The strap-on solid rocket boosters burn out 92 seconds into flight. At 138 seconds, the solid rocket boosters are jettisoned. Approximately 10 seconds before booster engine cutoff, the RD-180 is throttled down to maintain a 4.6 G vehicle acceleration. Approaching booster engine cutoff, just over 4 minutes into flight, the Atlas V is burning propellant at a rate of more than 1,600 pounds per second, 73 statute miles in altitude, 238 statute miles downrange, and traveling at a speed of more than 11,000 miles per hour. 6 seconds after booster engine cutoff, the booster stage is jettisoned. The first Centaur main engine start takes place 10 seconds after booster separation. The payload fairing is jettisoned 8 seconds after Centaur main engine start. Centaur and its payload are now in the first burn, the longer of the two RL-10 engine firings. Following first burn main engine cutoff, the Centaur and the ICO satellite enter a coast phase. Just over 22 minutes into flight, the Centaur's main engine is reignited for the second and final burn. Following the second Centaur main engine cutoff, Centaur and its payload enter a short coast period in preparation for spacecraft separation. At just over 30 minutes into the mission, Centaur releases the ICO G1 satellite for ICO Global Communications and Lockheed Martin Commercial Launch Services.
This is Atlas Mission Control, T-minus 4 minutes and holding. We are just a couple of minutes away from polling. We're about just under 3 minutes away from the polling of the launch team for pickup of the launch countdown. This afternoon's mission is dedicated to the memory of Atlas employee Lynn Deckard. Lynn served in the United States Air Force prior to joining the aerospace industry in 1983 as a software quality engineer. Her career was dedicated to the success of numerous launch vehicle and satellite programs. Joining Atlas in 2004, Lynn was the primary quality engineer for Atlas flight safety and software and quality focal for contingency planning, CMMI, ISO compliance, and quality dashboard development. Lynn was an integral and highly respected member of the software quality team and is sincerely missed. And as you can see, the vehicle is dedicated to her with a placard on the side of the launch vehicle in memory of Lynn Deckard. And we're inside 2 minutes away from final polling of the launch team. Again, our liftoff is scheduled for 4:12 p.m. Eastern Daylight Time. We're not working any issues. Weather does look good here with blue skies with some scattered clouds in the area. Temperature 70 degrees, and we don't have any significant concerns with either ground winds at the pad or upper level winds. Ground winds at the pad have been pretty consistent in the 12, 13 knot range with peaks of about 22 knots at the pad, well within constraint again. Again, the launch vehicle, spacecraft, ground systems, the weather, and the eastern range are all in a go status. A few moments away from our final polling of the launch team. This is Atlas Mission Control at T-minus 4 minutes and holding. The launch conductor will be polling the launch team in a few moments for the final go to pick up the launch countdown. There are 28 launch managers and engineering leads that are polled for their readiness status to proceed with the launch. This is the final status check before launch for all launch vehicle systems, including all the vehicle systems, vehicle's electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. The team will also verify that ground systems, including the computer-controlled launch system, or CCLS, is ready for flight, as well as telemetry and propellant transfer systems are ready for launch. The team will also verify that the eastern range operations and spacecraft are ready for launch. Some of the final launch processing steps just prior to launch include completing the propellant topping of the Atlas and Centaur stages and securing of both stages' vent valves. The team will also switch the vehicle from ground facility power to its own internal battery power. And the Atlas launch conductor, Ed Christensen, is now ready to perform a final polling of his launch team for a go to pick up the launch countdown.
Belco retract. Go. Atlas LO2. Go. Atlas propulsion. Go. Atlas hydraulics. Go. Atlas pneumatics. Go. Centaur engine chill. Go. Centaur pneumatics. Go. Centaur LO2. Go. Centaur LH2. Go. Has gas systems. Go. Airborne electrical. Go. RFFDS. Go. Flight control. Go. Instrumentation. Go. Communications. Go. CCQ. Go. Ground electrical. Go. Facility electrical. Go. Environmental control system. Go. Redline monitor. Go. Range weather and final clear to launch. Go. Quality engineer. Go. Op safety manager. Go. Atlas safety officer. Go.
Director recurring operations.
Go.
Spacecraft mission director.
Go.
CLS mission director.
Go.
Launch director.
Launch director is go.
Proceeding with the count. D0 is planned for 2012 Zulu. Set count to start at 200.
Polling is now complete, and the Atlas team has given the go for launch for the AV-014 launch vehicle at 4:12 p.m. Eastern Daylight Time. We'll be picking up the countdown in 1 minute 54 seconds. From T-minus 4 minutes until launch, you'll be listening to the launch conductor, Ed Christensen, and his ASOC launch team performing the final steps in the countdown procedure. At T-minus 3 minutes, the team will secure Atlas LO2 topping, At T-minus 2 minutes, the team will transfer Atlas and Centaur stages from ground facility power to each stage's own internal battery power. At T-minus 1 minute 58 seconds, the team will secure Atlas battery heater power. At T-minus 1 minute 55 seconds, the team will command the launch sequencer to start. At T-minus 1 minute 50 seconds, the team will secure the Centaur LH2 and LO2 topping. At T-minus 1 minute 40 seconds, the launch team will command the flight control system to launch enable. At T-minus 1 minute 38 seconds, the team will secure Centaur battery heater power. At T-minus 1 minute 37 seconds, the team will arm the flight termination system. 1 minute away from picking up the countdown now. At T-minus 40 seconds, the Centaur tanks will be stable at flight pressures. A final propellant status check is conducted at T-minus 25 seconds, and at T-minus 3 seconds, the booster engine starts. Vehicle motion occurs at T0, and again, we are not working any issues. We just had our go to proceed with the countdown and pick up the count in 36 seconds. We'll pick up the count at T-minus 4 minutes. This is Atlas Mission Control.
On my mark, time will be T-minus 4 minutes and counting. 3, 2, 1, mark. T-minus 4 minutes and counting.
This is Atlas Mission Control at T-minus 3 minutes, 49 seconds, and counting.
Denver address, Cape Winds on the MetNet.
Go ahead, Cape Winds. This is Denver address.
We have termination of LR5 at 60.0 K feet.
Great, thank you.
Cape Winds out.
During Atlas LO2.
Atlas tanks to flight pressure.
Denver address, Cape Winds on the MetNet.
This is Atlas Mission Control, T-minus 2 minutes, 46 seconds, and counting. The launch vehicle is now going to flight pressure. Once the rocket lifts off, it will take approximately 52 seconds to reach Mach 1, or the speed of sound. The mission will be complete in about 30 minutes after launch with the separation of ICO G1 from the launch vehicle.
Roger, Cape Winds out.
I can hear it.
This is Atlas Mission Control, 2 minutes, 4 seconds, and counting, and we're continuing to progress as planned. All systems go for liftoff as scheduled, 4:12 p.m. Eastern.
155.
Launch sequencer start.
150.
Securing Centaur LH2. Securing Centaur LO2.
140.
Launch enabled.
FTS arm.
Orca's arm. FTS count started. Inbound block.
"55 seconds and counting.
stable at step 3.
Status check.
Go Atlas.
Centaur.
20. 15.
This is Atlas Mission Control at T-minus 10, 9, 8, 7, 6, 5, 4, 3. Atlas engine ignition.
We have ignition.
1, 0, and liftoff of the United Launch Alliance Atlas V rocket carrying ICO G1 for ICO Global Communications and Lockheed Martin Commercial Launch Services. The G1 satellite will enable the new ICO nationwide mobile interactive media service, providing live mobile television, a new level of interactive consumer navigation, and enhanced roadside assistance capabilities.
Normally. We are supersonic at this point. We're now throttling back up. Atlas PU has gone to closed loop control. Everything is looking good. We're now operating the RD-180 at 80%. SRB chamber pressure is looking as expected. Coming up on SRB burnout, approximately 10 seconds. Everything continues to operate normally, RD-180, and we have burnout on the SRBs. We are throttling up the RD-180 back to 100% thrust, and we are seeing the effects in the PU system. Engine operating parameters look good for this portion of flight. Next mark event we are looking for is SRB jettison, approximately 30 seconds. Engine continues to operate normally. Acceleration levels right as expected, passing through 2 Gs. And we are seeing PU operate as expected, continuing to operate the RD-180 at 100% thrust. Coming up on SRB jettison. We have SRB jettison. Both brake wires show a good jettison of the SRBs. RD-180 continues to operate normally. We are now 28 nautical miles in altitude, 58 miles downrange, traveling at 4,900 miles per hour. And we have fired the pyro valves, activating the reaction control system. Everything looks good there. The RD-180 has throttled down to its 95% level as per the engine scheduler. Pressurization signature on RCS looks good. Acceleration continues to be smooth and as expected. Next throttle segment we are looking for is our constant 4.6 G limiting phase. Expect to hit that in approximately 25 seconds. Engine continues to operate normally. Normal PU activity. Acceleration looks good. We are past 4.5 Gs, approaching our controlling, and we are now controlling to 4.6 Gs. As expected, we have started boost phase chill down. Everything looks good there. Approaching our BECO time in approximately 20 seconds. Engine's throttling down to maintain 4.6 Gs. As expected, boost phase chill down continues. We have completed boost phase chill down. Coming up on BECO, we have booster engine cutoff, normal cutoff. Everything looks good. We have stage separation, good extensiometer, ignition, or we have pre-start on fuel and locks. Coming up on first burn, ignition, and full thrust. The RL-10 is up and running normally. Good start signature.
This is Atlas Mission Control at L plus 4 minutes, 39 seconds into the flight, and the flight is continuing as planned. We've had our mark events occurring as planned with the 2 solid rocket boosters burning out and jettisoning at 2 minutes, 17 seconds into the flight approximately. And just a few moments ago, as you heard, the booster engine cutoff mark event occurred as planned. Stage separation occurred. And main engine start number 1 and payload fairing jettison just occurred. So we're in the first burn with the payload fairing jettison having just occurred. We're now into the first burn of the Centaur, 9 minutes 57 seconds for this first burn, followed by a coast phase. The launch vehicle is now at an altitude of 108 miles, 95 nautical miles. Altitude distance downrange is 532 miles downrange from Cape Canaveral, traveling at a velocity of 12,616 miles an hour. This is Atlas Mission Control at L plus 5 minutes, 41 seconds, and counting. Again, the flight is continuing as planned, and while we wait for the next mark event, here's a look at the capability of the ICO G1 next generation satellite.
I'd say our vision for ICO is probably to be first, better, and different in a lot of different ways. In a lot of ways, we're really lucky. All good teams start from the top, and our chairman, Craig McCaw, has a long history of not only finding good people, getting the best of them, and developing a spirit and a collegiality and an environment where people can really thrive.
The fun part about working at ICO is really on the technology. We did a lot of study on the different types of technology that the satellite could support. Bob Day and his team created a very flexible satellite with ground-based beamforming that when I first started, they said it could do anything. It can support any technology, OFDM, FDMA, TDMA, CDMA, TCP/IP, peanut butter and jelly, whatever technology you wanted to throw at the satellite, it could support.
One of the great benefits of ICO, the company, as opposed to ICO MIM, the service, is the assets we're building can be useful in a variety of different ways. The satellite is not an ICO MIM satellite. It is a full-featured, able to do any kind of technology satellite, over which we're deploying ICO MIM. But there could be services in the future that could utilize the satellite in different ways that we haven't currently anticipated. And the great benefit of our system is its flexibility.
The MSS satellite that we've developed has an extremely large dish and is able to support two-way communications to small devices. So we said, we've got a great broadcast capability, a great interactive capability, so we crafted this product, MIM, that's a combination of broadcast over a large geographic area and then two-way interactive communication.
When we talk to people about MIM, we talk about a consumer service that is unlike any other. So the one thing we know is people want video. The second thing we know is people don't want to be constrained by where they get it. They don't want to have to go home necessarily and watch it. So mobile video is a natural development that follows on video at home or at business.
It's one of the few breakthrough technologies, as we were talking earlier, that's really available today. 10 to 15 channels of live video in your car, high quality, large screen video that you can actually watch, full-length movies on, regular live TV on, is something that nobody else is offering and nobody else can offer.
I think there's 2 or 3 things that can be added to navigation that makes it really infinitely more useful. One is the ability to get traffic information wherever you are, including when you're in the cities, including when you're in the country, to get real-time traffic information, real-time traffic reroutes, real-time on-screen displays of where the problems are ahead of you. And that just comes as part of the package. That is, you don't have to sign up for an additional service. You don't need a cell phone connection. You don't need a Bluetooth connection. When you get ICO MIM service, you get navigation and you get the interactivity all as part of the service.
Today, the existing emergency assistance, roadside assistance, works on the terrestrial cellular network. None of them uses satellite. Ours actually provides a satellite. Terrestrial networks cover roughly 2/3 of the geography of the U.S. So if you're in that other third of the country, you have no emergency assistance available to you. This is really something that is, we're going to be unique in offering truly national emergency services.
Five years from now, we will be the preeminent MSS player. We will be providing the most demanded consumer services with a integrated satellite and terrestrial network. I see MIM being a very large consumer phenomenon with millions of customers. I think success for us will be an increased recognition in the community that we have a service that's here to stay, that's going to provide a lot of competition to a lot of folks out there, and that we have hit upon the combination of services that's going to make us first, better, and different, not just in the MSS space, but in consumer products generally.
Success is having, good customer buzz, good customer feedback, people being excited about the possibility of being able to actually see this work. And they are excited. I mean, we've had a day's worth of it already, and people are excited.
We do have one challenge coming up, which is the satellite launching in March. If we are able to effectively integrate the signal from the satellite and from the terrestrial network and get the gains that theory says we should, that'll be, for me, a tremendous sense of accomplishment.
This is Atlas Mission Control at L plus 11 minutes, 55 seconds and counting, and we're continuing in the Centaur first burn. The mission's continuing as planned, with marked events having occurred as planned earlier. We had the SRB burnout and jettison. Looks like the SRBs ran just a second or two along, which is good. And the BECO and the separation of the Atlas vehicle from the Centaur and the main engine start of the Centaur, the first burn of Centaur, all occurring within just a few tenths of a second of the planned time for each of those events. So we're right on the plan here for the continuing of the mission here with MECO number 1. The first burn will conclude at 14 minutes 28 seconds into the flight, so just about 2 minutes away from MECO 1. Again, this is a 9-minute 57-second first burn of the Centaur, and the vehicle is continuing downrange at this time, and right now about 125 nautical miles in altitude and 2,294 nautical miles downrange from Cape Canaveral. Velocity is at 16,749 miles an hour as the vehicle continues downrange. The first burn will conclude over the mid-Atlantic, and then there'll be a coast period as the vehicle coasts for 8 minutes and 4 seconds over to the African coast, where the second burn of the Centaur will occur, 1 minute away from our MECO event.
All 10 operating parameters look good. RCS performance is as expected. Seconds to MECO 1. We are Open loop control on PU in preparation for MECO. Cutoff. Nominal MECO 1. 4S engines are on.
This is Atlas Mission Control at all plus 14 minutes, 29 seconds, and counting. And as you just heard, Rob Gannon reporting from the telemetry lab. We just had the MECO 1 mark event. The first burn of Centaur is now complete. We've entered the coast phase, 8 minutes and 4 second long coast phase. And this 8-minute coast will be fired by a second Centaur burn, main engine start number 2, expected to occur at 22 minutes, 32 seconds into the flight, and that will be a 5-minute and 9-second long burn. It will be followed by a 3-minute and 8-second coast and spin up, preparing for spacecraft separation, which is expected to occur at a mission elapsed time of 30 minutes, 47 seconds. This is Atlas Mission Control at all plus 15 minutes, 12 seconds, and counting. As I mentioned earlier, the ICO G1 satellite is the heaviest satellite to launch on an Atlas launch vehicle. The satellite was designed and built for ICO Global Communications by Space Systems Loral. Here's a look at the process of the building of the satellite.
The ICO G1 program began as a study in January 2005, and 6 months later developed into a collaborative effort between Space Systems Loral and ICO to design, manufacture, and deliver the sophisticated ICO G1 spacecraft and corresponding ground system.
The ICO program consists of 2 systems, the ground-based beamforming system and, of course, the satellite.
The satellite is over 27 feet tall, weighs more than 6,700 kilograms, and with the solar arrays deployed, spans over 100 feet. The mission life of the satellite is 15 years. However, with the very capable Atlas V launch vehicle, there's fuel for significantly more.
The satellite and ground-based system together provide unprecedented flexibility and power for anytime, anywhere information, entertainment, and communications.
ICO is the next generation communication satellite for mobile satellite services. We're developing an advanced hybrid system that's going to use the satellite plus terrestrial systems to provide mobile interactive media to customers across the whole U.S. These services will include video, data, voice, and other applications running over those interactive data streams.
The satellite uses an intricately designed 12-meter unfurlable reflector that was built by Harris Corporation.
The benefit of this large antenna is the user terminals can be smaller and more compact and convenient for ICO and its customers.
Innovative approaches and advances in technology on the ICO program were not limited to the satellite.
One of the unique things about our system is that it's an advanced hybrid system. That means we'll be utilizing the satellite services and services coming from terrestrial towers. This allows a higher quality of service for our customers and additional sets of services to be delivered using both aspects of that hybrid system.
ICO G1, a 16-kilowatt capable satellite, will work with the ground-based beamforming system and an ancillary terrestrial component, allowing ICO to supplement nationwide coverage offered by the satellite with cellular-like terrestrial service. The ground-based beamforming system gives ICO extraordinary adaptability with the capacity to change in orbit spot beam size and location, power, and the spectrum used. The enormous technological advances implemented in the ICO G1 program were the result of dedicated teamwork.
On a challenging program like ICO, everything is a team effort. And on our program, the people that supported us and the teamwork that they exhibited throughout the program has been amazing.
Teamwork also meant a close working relationship between Space Systems Loral and ICO.
ICO is a first-class organization, starting with their CEO, Tim Bryant, their president, Craig Jorgens, and their technical team headed by Bob Day.
The working relationship with Loral has been excellent. Building a cell like this necessitates very close cooperation between the manufacturer and the customer.
Space Systems Loral made a company-wide commitment to ICO Global Communications in support of the highly challenging and technically advanced ICO G1 program.
It wasn't just the program team that made this program a success. It was all of Space Systems Loral, starting with the executive management, including Pat DeWitt, John Shelley, Chris Hober, and Chris Goodman.
The ICO G1 spacecraft is one of the world's most advanced satellites to provide mobile services. Space Systems Loral is proud of its contribution to this growing technology and its instrumental role in making ICO G1 a reality.
This is Atlas Mission Control at L plus 19 minutes, 42 seconds and counting, and the mission is continuing as planned. The vehicle continues downrange. Mark events have been occurring as planned. We're continuing in a coast phase, 8 minutes and 4 seconds in duration, and we're approaching here within a couple of minutes Centaur main engine start number 2. The Pratt & Whitney Rocketdyne built RL-10 engine will ignite at 22 minutes, 32 seconds. Mission elapsed time, which is just 2.5 minutes away. The vehicle is at 105 miles in altitude and 4,300 miles downrange from Cape Canaveral, traveling at a velocity of 17,833 miles an hour. Again, all mark events have been occurring as planned. Coast orbit data looks good. This is Atlas Mission Control at L plus 20 minutes, 35 seconds, and counting.
Approaching our pre-MES 2 operations. Approximately 20 seconds, we'll be pressurizing the propellant tanks on Centaur in preparation for second ignition of the RL-10. And we've begun to pressurize the propellant tanks. Everything is looking good there. Tank pressure is continuing to increase as expected. Everything is looking good. Next event we're looking for is LH2 pre-start in approximately 30 seconds. We have LH2 pre-start. Inlet pressure looks good. And LH2 pre-start has initiated in trickle chill mode. Everything is looking good for MES2. We have full thrust. Engine is up and running normally. Good steady state operating levels. Start signature looks good. We are closed loop on PU.
This is Atlas Mission Control at L plus 22 minutes, 49 seconds into the flight, and we've had our second Centaur ignition, main engine start number 2 just occurred, and that event is a 5-minute and 9-second long, starts a 5-minute, 9-second long burn, which will be followed by MECO 2 at 27 minutes, 41 seconds into the flight.
Operating parameters look good. This is a nominal 4-minute, 12-second second burn of Centaur. Everything is looking good.
And you're continuing to listen to Rob Gannon from the Atlas Telemetry Lab providing launch vehicle ascent data.
And Centaur continues to make a small fuel correction. Not unexpected. Steady state operating parameters on the RL-10 look good. And we are seeing our thermal conditioning firings on the reaction control system during the burn. Very few roll control firings. And Centaur PU is beginning to modulate around nominal mixture ratio. Engine parameters are looking good. second burn continues, nice and smooth. Everything looks good. PU is now operating down at a nominal mixture ratio, and engine operating parameters are reacting as expected as we change MR. Vehicle is accelerating smoothly at just over 0.7 of a G. Everything is looking good. Passing through 25 minutes into the mission, we are in our second burn of Centaur. Everything is looking good.
Range coordinator, DRO 20.
DRO range coordinator 20, go ahead.
You have a liftoff time?
Roger that, stand by.
We are approaching 2 minutes to a nominal MECO 2. Engine parameters continue to look good. PU operating normally. Vehicles accelerating smoothly at over 0.8 of a G. Engine parameters are very smooth, right as expected.
This is Atlas Mission Control at L plus 26 minutes, 5 seconds into the flight. Liftoff occurred as scheduled on time at 4:12 p.m. Eastern Daylight Time. Did not have any issues in work during the countdown. Liftoff occurred as planned at the top of the window, and flight is continuing as planned. We have a nominal flight thus far, coming up on our MECO 2 mark event in just over a minute.
Very good data here in Denver. We're approaching 1 minute to MECO 2. Everything continues to look good. Approximately 30 seconds to MECO 2. We've gone open loop on Centaur PU. Engine is responding to the change in MR as expected. We are approaching cutoff or second and final burn of Centaur for this mission. Coming up on MECO. Cutoff. We have a normal shutdown signature for guidance commanded shutdown. We have gone to 4S settling as expected. Venting down the LH2.
This is Atlas Mission Control at L plus 27 minutes, 55 seconds and counting, and we just had the MECO 2 mark event, the main engine cutoff number 2 of the Centaur upper stage. We're now in a 3-minute, 8-second period in which we'll coast and spin up, coasting and separating from the Centaur upper stage and spinning up in preparation for the separation of the G1 spacecraft. Expected to occur at mission elapsed time of 30 minutes, 47 seconds.
Nominally, and
vehicle's 194 miles in altitude. Distance downrange is 6,760 miles downrange, and traveling at 22,633 miles per hour velocity.
We're in slightly over a 3-minute coast phase between MECO 2 and spacecraft SEP. Everything is looking good.
Under 2 minutes from spacecraft separation.
Settling activity is as expected. Vehicle rates look good. Bus and battery voltages and tank pressures also look good.
And for those of you watching the live broadcast, you continue to watch the satellite toolkit, real-time imagery, delayed just 2 to 4 seconds. And this is imagery driven by data on the launch vehicle that depicts the actual flight of the vehicle. You can see as Centaur is orienting to separate the vehicle.
Vehicle rates are nulling out. We have achieved spacecraft separation attitude. We are now approximately 1 minute to spacecraft separation. Approaching our tumble check milestone. And we have completed tumble check. Everything passed as expected. Vehicle rates are nominal and right what we expect to see. Coming up on spacecraft separation, approximately 10 seconds. We have spacecraft separation. Both brake wires indicate a satisfactory separation of the ICO G1 spacecraft.
And we have spacecraft separation. We have just seen a successful mission for ICO, Lockheed Martin Commercial Launch Services, and United Launch Alliance. The team has completed the mission successfully. Liftoff from Launch Complex 41 at Cape Canaveral Air Force Station occurred at 4:12 p.m. Eastern Daylight Time. Again, liftoff occurred as scheduled. At the top of the window, we did not work any issues during the countdown, and we had a liftoff as planned with a nominal flight, mark events occurring as planned, and separation occurring just moments ago, as you heard. So the team here at the ASOC very excited to have this mission complete. The ICO team's thrilled with many of the folks here applauding here at the ASOC the completion of the successful mission. In the coming weeks and months, the ICO G1 satellite will be used to conduct extensive testing and trials for ICO Global Communications in preparation for rollout of the ICO Mobile Interactive Media Service. I'd like to thank Rob Gannon from the Atlas Telemetry Lab for his expert play-by-play of key launch and mission events throughout the launch vehicle's ascent. For more information about the Atlas V and upcoming missions, please visit our website at www.ulalaunch.com. This concludes live coverage of this afternoon's Atlas V launch. Post-launch comments will follow shortly after the conclusion of this broadcast, anticipated to be approximately 15 to 30 minutes from now, and Jim Sponek, Vice President of the Atlas program, and other ICO representatives and Space Systems Loral senior executives will address the team, and again, that's going to occur in 15 to 30 minutes. They are expected to acquire the spacecraft at approximately L plus 45 minutes, so coming up in 13 minutes or so, and it's possible that we'll return then. So post-launch comments will follow shortly after the conclusion of this broadcast. Again, I'm Don Spencer. Thank you for joining us, and we leave you now with one last look at the spectacular launch of the United Launch Alliance Atlas V rocket carrying the ICO G1 for ICO Global Communications and Lockheed Martin Commercial Launch Services. Have a good evening.